these are units of energy, because energy is energy. There's different kinds of energy, and so we use different measurements to measure different kinds of energy, and sometimes we use different measurements to measure the same kind of energy, but you convert between them. And before we really start with all this, let me just give you an example. What is that distance? Wrong! It's 25 centimeters. It's a third of a yard. It's 1/5,000th of a mile. Get it? I mean, the point is that you could describe this in feet, which seems the most appropriate considering that it is about 1 foot. You could describe it in meters or centimeters or millimeters, kilometers, whatever. You could describe it in miles. You could describe it in astronomical units, which I believe is what? An astronomical unit is how far light travels in 1 day, I think, something like that. You could describe this in yards, inches, etc. But the point is, the distance itself doesn't change. That's the first thing. When we start talking about all these, and your head starts to spin, because you literally can convert between any of these and any of the other ones. Just really quickly, who thinks that assuming that we put a 1 in front of any of these, 1 calorie, 1 British thermal unit, 1 foot-pound, 1 joule, 1 barrel of oil, 1 TNT, or 1 watt-hour, which is the biggest? Which has the most energy? Josh says?
Barrel of oil.
Barrel of oil, okay.
Ton of TNT.
TNT, okay. Any other ideas? Okay, well, I'm just saying, like, if you had one of them, like if I was to say which is bigger, 1 inch, 1 mile, 1 astronomical unit, 1 astronomical unit would be the biggest, but...
Wait, is foot-pound? Is that how you measure torque?
Yeah, that's right. A torque wrench is measured in foot-pounds, yeah. So, okay, so how many people say barrel of oil? I'm not going to vote, because I already know the answer. Josh says barrel of oil. Anybody else? Ozzy, are you voting? No? Okay. How many people say ton of TNT?
Bam.
Okay, so we've got about 5 people. For the people at home, we have about 5 people that say ton of TNT has more energy, and 1 brave soul who says a barrel of oil has more energy, and then everybody else is weak and will not have an opinion. What is the matter with you people? Have an opinion.
Well, I was going to guess a different.
What's that?
What do you think is the difference?
What do you think it is?
Joule?
You think it's a joule? Okay. All right.
Watt-hour.
Any other, well, we're going to learn what a joule is presently.
Well, it's relevant to what it's actually powering, isn't it?
Well, not exactly. No, you're right. You're going to use the right unit for the right job. Like, you're not going to measure, calories in tons of TNT. And generally, you're not going to look on the back of your food label and see the energy measured in watt hours, although you can convert between calories and watt hours. Thank you. More recycling. All right. Anyway, let's start talking about these, and at the end we'll have an answer as to which is biggest, and hopefully we'll all learn something. All right. Hey guys, I'm over here talking about science. All right. So a calorie, and I'm going to give you the definition for each of these, and after them I'm going to give you a couple of relevant conversions so that you can keep these in mind as far as how they relate to each other. So a calorie is I'm going to write the amount of energy required for the first one, and then I'm just going to write what it is for all the rest of them, because it's always the same thing. The amount of energy. Does anybody know what kind of energy a calorie measures? Heat, that's correct. People think of a calorie as a measurement of getting fat, but it's really not. That's just because of a lot of cultural reasons. But it really is the amount of heat energy required to raise the temperature
Wait, something like peanut lab or something.
of 1 degree, of 1 gram. What are 1 gram of water? But before you write anything after 1 gram, let me ask another question. What are other ways to quantify 1 gram of water? There's 2 other units that are also 1 gram of water. A milliliter is 1, which is also known as a centimeter cubed. That is correct. Very good. Thank you. A gram of water is also measured in volume as milliliters or centimeter cubed. The amount of energy required to raise the temperature of 1 gram of water up 1 degree Celsius. Okay, so that's what a calorie really is. Let me look and see who this is. If it's my family, I probably need to get it.
I hate when I'm scared you. I can't believe it's like a bag from here.
I don't know who this is, so it's Mr. Pasha. Hello? Hey, Mr. Pasha. I just have a second, but it's an automatic, so I don't think you can let's schedule for a payday. But I got a class right now, so I gotta go. I'll email you back, and we'll figure it out. Okay? You know what? That just might work. What time do you need me to have it in there? I can do it. Alright, sorry about that, folks. I will edit that out. I apologize. Mr. Pasha was waiting to hear from me. Okay, folks. The amount of energy required to raise the temperature, 1 gram of water, 1 degree Celsius. Now, the calories listed on the back of a food label, that's exactly what this means. I take these sliced almonds and I take a...
Can we have some?
I'm sorry.
Actually, they don't even look that good.
They're delicious.
It's a little harsh right there.
I'm sorry. I didn't mean to eat that in front of you. I wasn't trying to be a jerk. Thank you for reminding me.
Yeah, since you reminded me.
If I burn this, it will release heat. You measure that in a calorimeter, remember with the water and we did the peanut lab, right? Same thing. And so this would raise the heat of the water up a certain amount, and if it was 1 milliliter of water, you could literally tell how many calories it was by how many degrees the water went up. And you're going to be doing some problems working with that later, so I'm not going to torture you with examples right now. But I will tell you one more thing. The calories on the back of your food labels are actually bigger. They're big calories. You notice how this is lowercase? Uppercase calories is 1,000 little calories. So 1,000 of these little calories is 1 uppercase calorie, also known as a kilocalorie. Okay.
Wait, so one of the bag calories is 1,000?
Yeah, one of the food label calories is 1,000 little calories. So technically, 1 food calorie will raise a kilogram of water up 1 degree Celsius, right? Because it's 1,000 times more, and that's 1,000 times more than
Wait, what does it say?
kilocalorie.
Oh, I thought it said kilocalorie.
Looks like kilogator.
Yeah.
I suck at writing. Okay. Okay, can we move on? All right. Let's see. I'm gonna do another heat-related unit, the British thermal unit, and then I'll do the other heat-related ones, and then we'll do the remaining ones. So a British thermal unit is another heat unit. It measures an amount of heat, and British thermal units is what usually gets used with things like heating and cooling systems, like your air conditioner or your heater, because it's a larger amount. And so a BTU is I'm just going to write heat required to raise 1 pound of water up 1 degree of the dreaded Fahrenheit, not Celsius. So Fahrenheit and Celsius are a little different. What?
The British people use Celsius.
They do now, but this term was coined before the British reluctantly finally became the next to last country to go over to the metric system. We are not there yet here in the States. We can be proud We can be proud of being the last country to not adopt the measurement system that the rest of the world uses. Go us.
America.
America. Oh.
America. There's no name.
Those of you that catch the reference, I'm glad I stopped myself. Yes, I'll edit that out. Okay. So a pound of water up 1 degree Fahrenheit as opposed to a gram of water up 1 degree Celsius. Much bigger. So this is a larger amount of heat. In fact, what's the conversion? One BTU is 252. Is it little calories? I think it's little calories. Yeah. Now I have the Team America song stuck in my head, and that's never good. When you don't have filters, like I often don't have filters, it's not good to have the Team America song stuck in your head.
Whatever.
Anyway, I'll be like in a meeting later, and someone will be like, "America, what? Yeah, what?" Anyway, sorry. I should shut up more. All right, so here's another heat-related unit, a joule. A joule, unlike a calorie, is usually used to measure fuel-type energy, fuel-type heat. It's still another heat measurement, and it's another one that you measure as far as raising the temperature of water. I'm just going to give you the conversion. 4.2 joules equals 1 calorie. And there's also 1,000 little joules equals 1 big joule or kilojoule. Or kilo meaning 1,000 joules. Okay, and I'll give you a BTU conversion also. Never mind, I'm not going to give you any other conversions. I don't have them handy.
Wait, but isn't...
But, okay, I have to also correct something. There is no such thing as a little joule. There is just K-joule, kilojoule.
But, so then isn't... couldn't you just convert it using 252 little calories?
Yes, that is true. It's just, but it becomes, yeah, so if we... Yes, we could.
Is that
We could do that.
1.5 or 50?
This? 1J. One.
Oh.
Oops.
Yeah, you messed it up.
Wrong way. 1,000 joules is 1 kilojoule. Who is he? Hey, Corey, what's up? Come on in. You're kidding. Awesome. What do you got? Did you make something? That's for me? Did you guys make these?
What are you telling him? Now, what are you telling him? Did you make them? Say the word. Say the word. Did you make them?
You did. Thank you very much. Let me look at you. I'm actually really hungry right now. Chocolate chip cookies. Peanut butter chocolate chip cookies.
What do they do? It depends how long you let it sit. If you let that sit a long time, you can
Thank
shake
you,
it.
Corey. See you later. Stopping in.
It is.
Thanks for the cookies.
Don't shake around, Jesus.
All right.
Deep breath out of this.
Where were we? Oh yes, we were correcting my mistake over here. Okay, so that's all. That's all I have to say about that. That's as much Forrest Gump as you got.
I was gonna say, you were pulling out some Forrest Gump.
Okay, so then we get to the dreaded barrel of oil, which is defined as the energy released by burning what? The energy released by burning what?
Oil.
How much oil?
1 barrel.
A barrel of oil, that's right. 1 barrel, 2 R's, 1 L, which is 42 gallons.
How did they decide that?
I think that way back when the Saudis were like, "Boy, we got a lot of oil. What are we going to put it in?" Somebody said a barrel, and somebody said, "Well, I got these 42-gallon barrels here," and that became a barrel of oil. Yes. I don't have any passes, but I will write you a pass. The energy from burning a barrel of oil, which is 42 gallons. You're going to. There you go. That's all I got. So a barrel of oil. And how big is a barrel of oil? How much energy is in a barrel of oil?
42 gallons worth of oil.
5.8 times 10 to the 6th BTUs. What number is 5.8 times 10 to the 6th? Just checking to see if people know their scientific notation.
Isn't it?
Other way.
6 zeros after 5 8.
Yeah.
That's right. 6 zeros after 5.8, and so 5 million. No, not
5.89.
5.8 million. 5,800,000 BTUs in a barrel of oil. Now that's a lot of energy, folks. So far, this is our leader. So I'm sorry. I forget who said Joules, but you don't have to raise your hand again. You're a little bit behind on that one.
Blame it on Rob.
Yeah, Rob, you gotta stop whispering the wrong answers to BJ. Okay, so all right, now we get to the ton of TNT, which is not surprisingly the energy released by exploding 1 ton of trinitrotoluene, TNT. And I don't want to write it wrong. It's 4. Here we go. This is where we find out. 4.14 times 10 to the 6th BTUs. We have a winner. It is
Again.
barrel of oil. It has the most energy. Can you believe it? Who knew?
Nuts.
I knew.
He knew. Did you actually know that? Or you were just guessing?
On TV.
Science.
What?
Like wow.
Science?
Science.
Science. If you think about it, what form of energy does an explosive convert from and to? I mean, what kind of energy? It's chemical. Both of them are chemical energy, but this converts to heat. What is this generally used to convert to?
Motion.
Motion, mechanical energy, right? And so yeah, it releases heat incidentally, but I guarantee you're going to get a bigger explosion from a ton of TNT than you are from a barrel of oil. So again, different measurements for different things. What's that?
It's hard to clean up oil.
It is, yeah, that's true. That's true. Okay, so do you think you could maybe get that just a little bit? Do you see where I want to get like this whole area in here? Thank you, Sophie. I appreciate
Who's watching?
Yeah, I got it.
it. Awesome. Who is watching at home?
Hello.
Oh yeah, Mello is, and I had several people this morning.
Mello could just copy one of our notes.
Yeah, well, no, he's gonna watch this.
Mello!
What's the secret? What's the secret word?
Shout out to Ramona.
What's the secret
Shout
word?
out to my homie Ramello.
What's the secret word for Romello to have to tell me after he watches this? Gourd squash. Gourd squash is the secret word. So we're gonna ask Romello what the secret word is. I don't care. It's 2 words. The secret 2 words are gourd squash, and so just
He
gourd
doesn't have
squash.
time to watch this.
Make time.
What's your first part?
Anyway, okay.
Mello's
Last
not a
one.
person.
Watt hour. Watt hour is a measurement of electricity. And a watt hour is the electrical energy to light a 10 watt bulb for 6 minutes. Now, I want to say something about this. What would be a better way to say this, watt hour, than lighting a 10 watt bulb for 6 minutes?
1 watt per hour.
A 1 watt bulb for an hour. Can you see that that would be the same amount of energy? So this bulb, in other words, a 10 watt bulb uses 10 watts in 6 minutes. A 1 watt bulb would use 1 watt hour, 1 watt for 60 minutes, right? 10 times less for 10 times more. Same thing. If there was a 100 watt bulb, it might run it for, what? 6 seconds, I think? But anyway, there's no such thing as a 1 watt bulb, really. I mean, maybe a Christmas tree bulb might be 1 watt, but I think those are 0.5 watts. But anyway, the point is...
Or 0.25.
Something, yeah, okay. Let's not split hairs. A 10 watt bulb, just to give you some perspective, is about a nightlight bulb. Those of you that still sleep with a nightlight, your nightlight bulb is 10 watts. That keeps you safe from monsters. And there is another. Hold on, you guys. We're right at the end here. Let's keep it. Shh. I want to say one more thing about this. No, not on the DL. That's different. Yeah. Well, right. Isn't that different though?
No.
Keep it on the DL is like
No.
something secret, like sketchy.
Oh yeah, you're right.
Yeah. Right.
You know more than me, Mr.
Good answer. Yeah. Thanks. All right. The other thing is that's supposed to be lowercase k. Kilowatt hour. A kilowatt hour is just another, it's just more energy. How much times more? How many times more?
1,000.
Close, yes, 1,000 times more. Watt hour, kilowatt hour. Kilo always means 1,000. Kilojoule is 1,000 joules. Kilocalorie is 1,000 calories.
Kill cows, kill 1,000 cows.
Hello. Oh, you're back. So a kilowatt hour is going to, again, they play fast and loose with the bulb units here, but it will light a 100 watt bulb for how long? Just curious. How long will a kilowatt hour light a 100 watt bulb for?
My shoe's not on my
What? What
foot.
did you say?
Say that. Ask the question again.
Well, if a watt,
6 hours.
6 minutes.
a watt hour is 10 watts for 6 minutes, or 1 watt for, yeah, exactly. It's 60 minutes. 100 watts for 60 minutes.
Yeah.
Okay, like
Is that
1,000
right?
watts? What?
That doesn't make sense. Less times.
Well, a 100 watt bulb takes 10 times as much energy.
Let's go back.
Wait a minute, is it 60 minutes? Hold on. Check this out. Check this. I think I might have written that down wrong.
100 watt bulb will require more.
Whoa! No, wait. 10 hours.
No, you suck.
Was that, wait, I? Suck? No, okay. She sucks, alright, that's acceptable. Don't tell her she sucks though, you're hurting her self-esteem. Her! No, you're hurting her self-esteem too. Now you stop it. I think the state of Vermont requires me to hit you if you say that again. I'm pretty sure. I'll have to check. Lachlan, do you have any guidance on this? You're in the...
I think it's fine.
Yeah, okay.
Wow.
That is so making it into the bloopers reel. Okay.
bloopers.
Alright, everybody. So,
Bloopers are the best.
100 watt bulb for 10 hours. Alright, so these are all your energy units, folks. The assignment that goes along with this, Romello, could you do me one more favor? And bring that over here?
But I have a question.
Oh, okay, yeah,
We
sure.
didn't do footnotes.
Oh my god!
I'll think of something back.
I'm sorry. Not yet. A foot-pound is totally different. A foot-pound is a unit of force. And if I'm not mistaken, well, a foot-pound is the energy of 1 pound moving over 1 foot, I believe, on an unobstructed surface. Like, so I think that it's when 1 pound acts through a distance of 1 foot. And I'll be honest, I'm not 100% sure if that means according to gravity or having to push 1 pound across a smooth surface. I think it's 1 pound moving through the force of gravity. I will look that up and get back to you on that. But so a foot-pound is a unit of actual force. Like I think Lachlan said, is that how you measure torque? Does anybody know what a torque wrench is? A torque wrench is a wrench that you set to only exert a certain amount of force. Like if you're tightening the lug nuts on your tires, they're only supposed to get tightened to a certain amount of force, and so you turn it. Like or if you're tightening something, it says tighten to 10 foot-pounds. So you turn your torque wrench to 10, and no matter how hard you push, beyond the force of 10 pounds, it'll just spin free, and it won't tighten it anymore. Or you know what I mean? So if you tighten it up to 12, then it would tighten a little bit more before it spun free. Okay, so anyway, that's a foot-pound, and that's for things like pushing things and pulling things. Foot-pounds. Okay, so these can all be converted between themselves, and if you look on page 99 where all of these are actually listed in your textbook, you'll see that there are also conversion factors. When you do your next work, which if you wouldn't mind, could you shift this one more time over to here?
You should just keep it on your desk.
Activity 3.8, this is what you'll be doing for the rest of the class. On page 100, that is numbers, that's numbers 6, 7, 9, 10 through 14, and 18 through 20. You're going to use these units, and you're also going to use the conversion factors between them on page 99. Yes? Go ahead. Thank you very much.
Thank you
Have a nice day.